Okay, we're going to go over Charles's gas law today. You should have gone through the notes already. Charles's gas law relates volume and temperature of a gas. Be sure you have this formula written down. So you'll see that it's V1 over T1 equals V2 over T2. So again, your V is your volume. One stand for initial, so you have your initial volume over your initial temperature equals your final volume over your final temperature. An important note is that your temperature has to be in Kelvin when you plug it into your formula. So to go from Celsius to Kelvin, you just add 273 to it. So say you want to convert 30 degrees Celsius to Kelvin, you would just take 30 and you would add 273 to it, and then you would get 303 K, which stands for Kelvin. Also note that there's no degree symbol when you're writing the units for Kelvin. Okay, you just write K. Okay, so we're going to scroll down to the first example. And it says 10 liters of oxygen in a piston at 300 Kelvin are warmed to 600 Kelvin. Its pressure does not change. What is the new volume? Okay, so again, we're using our new formula. V1 over T1 equals V2 over T2. So let's identify our variables and then we'll plug in. Okay, our initial volume V1 is going to be 10 liters. Our initial temperature T1 is 300 K, so it's already in Kelvin, so you don't have to convert. Our V2 is what we're solving for, and our T2 is 600 Kelvin. Okay, so we're going to plug into our formula. V1 10 over T1 300 equals V2, our unknown, over T2, which is 600. Okay, there are different ways to solve this, and you can do what makes most sense to you, but I like to cross multiply and divide. So I'm going to start by multiplying 10 times 600, which will give you 6,000. And then we'll multiply the other side, V2 times 300, which will give you 300 V2. Okay, we got to get V2 by itself, so we're going to divide both sides by 300. So when you do that, you're going to get 20. And we need our units. So remember our V1, our initial volume was liters. So this is also going to be liters.